that particular node. The node is the activity and the equipment that you require. So this diagram also helps you to enhances the communication among project participants. So each one will know what job you are doing, and then your job should finish first, then followed by my job, the interdependency, then who is depending on whose job. Okay, provides an estimate of the project's duration. So within this diagram, you're going to put in how long, how many days or how many weeks you're going to complete that particular activity. Provides a basis for budgeting cash flow. So within that activity, do you need how much money cash in order to finish that task or that job within the activities there? Identifies activities that are critical. That means that activity you cannot delay. If you delay, then your project going to be delayed. So those are called critical activities. Highlights activities that are critical and cannot be delayed. So that's the meaning that I explained just now. Help the managers get and stay on plan. So that's why helping the manager to monitor so that you are always following the plan and you are not going to be behind time. Now this one is the previous one, the example given 2 weeks ago's lecture on the WBS work packages that we are going to draw from this WP to the network diagram. So that's why I asked you, you must make sure you prepare WP in order to carry on with this network diagram. Otherwise, you can. From this previous lecture notes, this is the part that we draw the WBS, which is the circuit board. And under circuit board, you have design, production, test, and software. If you go back to this slide here, that's the from previous lecture notes. So you can see under circuit board, we have the cost account, which is come from design, then from the production, test, and then software. These are the 4 departments that from the OBS that involved in developing this circuit board. So here, how to draw this part here. Okay. So now you can draw. See, so just now I mentioned that under design, you got under this producing that WBS for the circuit board involve design, production, test, and then software. So how to draw this in network diagram? So this is the activity network for this circuit board work packages. So this one you can see the arrow here, it shows the interdependencies and which one comes first, which one comes later, which activity comes first and followed by which one. So here A here represent D11, D12. So you can see this is WP D11, D12. That means you start with design first. You got the 2 work packages. You start with these 2 under the activity called A. So the activity A, you can have you can include more than 1 activities. You see, not necessarily must be 1 activity. You can have 2, 3, or 4, depending how many you have. You group all these activities and put under one node here, or this whole thing is called activity. So these are all the WPs. So after you have completed the A, the activity A, which cover these 2 design tasks here, then you continue with the next task, which is called the P-10-1. So this is called production unit, and this is actually the work package that you pick out for P-10. So this is under production. So you carry on with F, which is S22-2, which is software, and lastly, which is K, is the test T-13-1. So this is the way to draw your activity diagram. So if you want to draw it this way, another way to draw, you can put it instead of put the D11, D12, all this label which people may not be able to understand, you can put go and type the actual what is the activity name. So example here, the A here under the activity A, what are the work packages you can type inside, which are the specifications and then documentation. You can see from here, specification and documentation, this one here under design. So that is the D11 and D12. So you replace all this numbering with the actual name. Then B is Proto 1, C is a preliminary software, D is a final Proto 2, F is final software 2, and then K test. So you can see there are some numbers down there, 2, 5, 3, 4, 2, 3. So this one means the duration. So if, for example, A to complete this 2 here, it could be, it means 2 days or 2 weeks. So that shows, this number here shows the duration. So in this activity diagram, it will tell you how long you need to finish that activity. So one activity can cover, you can cover, take in more than 1 WPs, okay? So now you're going to learn how to draw the network activity diagram. So before you can start drawing the network diagram, you need to learn some of the terminologies first, the basic terms that you need to understand. So the first term is called activity. So activity means an element of the project that requires time. That means if you perform an activity, there's a time consumed. You need time to finish that activity. So next term is called merge activity. So this is an activity that has two or more preceding activities on which it depends. So merge activity means you got many arrows that going in. You are merging many activities and then go into the activity. So that activity that got many arrows going in is called the merge activities. And the last one, the last term here in this diagram here is called parallel or concurrent activities. So these are activities that can occur independently and if you desire, not at the same time. So, okay, can you tell me in this diagram, which one is the merge activity and which one are the parallel or concurrent activities? Which one is the merge activity?
D.
Yes,
D.
that's right. Which are the parallel or concurrent activities?
E.
ABC.
Yes, that's right. A, B, C. So that means you want to start A, B, C together if you want to, yes, because they are independent, you can start together. But the merge here, you see, you must finish A, B, and C. After you finish, all of them go in and then go and start execute the D. So D cannot start until A, B, C all completed. So that's why D is a merge activity, dependent on all on A, B, C's completion, right? Okay, next terms. The next two terms here will be path. It's a sequence of connected dependent activities. So a line connecting to another line. So this is known as a path. So in this diagram, can you see what are the paths? What are the paths?
A to B, B to D.
Yes, that's right. A, B, D is a path. C to D, another path. Okay. So next term, critical path is the longest path through the activity network that allows for the completion of all project-related activities. The shortest expected time, another term is it means the shortest expected time in which the entire project can be completed. Delays on the critical path will delay completion of the entire project. So that means that path is very important. You cannot delay. If you delay any of the activity along that path, you're going to delay the project completion time. So you look at this diagram here. The ABD is a path, CD is also the path. And you can see there's in the bracket, there's a note here, assumes that minimum of A plus B, that means the activity A plus B, the time, is greater than the minimum of C. So that means, let's say C is 5 days. So A plus B could be 8 days or 10 days. That means longer than C in length of times to complete the activities. So in this diagram here, A, B, D, and C, D, which one is the critical path? If C is 5 days, and then D is, let's say, 10 days, and then A and B together plus together is 8 days, D is 10 days. So which one is critical path? Which one?
C.
The path you have to give the length, the line starting until the arrow ending.
CD.
You listen to my question again. C is just I mentioned is 5 days, right? D is 10 days. The A and B together is 8 days. So which one is the critical path?
ABD.
Sorry?
ABD.
Yes, that's right. Because C is, you need to complete C, activity C is 5 days to finish. D is 10 days. So the total, the path to finish C and D will be how many days? C is 5 days. D is 10 days. Total is how many days?
15 days.
Yes, 15 days.
15.
Just now,
15
yeah,
days.
15. C to D is 15. So just now I mentioned that A plus B together, the activity. So A and B, let's say is 4. So total is 8 days. D is 10. So the activity for A until D, how many days?
18.
Yes. So which one is longer now?
ABD.
Yes. So ABD is longer, is 18. C to D is 15. So ABD will be the critical path. You understand now? The longest path that you require to finish that whole project along that path, then ABD is the critical path and not CD. So do you understand how to differentiate now? That means the longest length you add together, that is called critical path. Okay? Understand now? Okay, next.
Understand.
Yeah, good. Okay, next, there are two more terms here. Terminology, the next term will be event. So event means a point in time when an activity is started or completed. It does not consume time. So that means the activity A started, that's it, it's an event. The B started, B ended, that's it. There's no time, there's no duration involved. It's just the starting point only or the ending point. Okay, understand the term event. That means no time consuming. You don't have duration one. Okay, no, don't have 1 minute, 2 minutes, no such, or 1 day, 2 days, or 1 week, 2 weeks, 3 weeks, no such thing. Just say started, ended, that's it. It's just like ending of the milestone. That's it, that's a point. So next term is called burst activity. So this is an activity that has more than one activity immediately following it. So that means you must have more than one dependency arrow flowing from each. That means from the activity, there are a lot of arrows going out. So in this diagram here, which one is the burst activity?
A.
Yes, that's right.
A.
Yeah, many arrows coming out from the activity, that means it is a burst activity. So if many arrows going into A is called what activity?
Merge activity.
Yes, good. Okay, so now you know how to differentiate. Yeah, merge and burst. So you need to know these two terms. Okay. So now you, after understanding all these basic terminologies, now you can start to draw the diagram. Network activity is called, the approach is known as activity on node. So in short form, it's called AON. So this one, when you draw AON, you are using a node to depict an activity. So you can see this diagram here. A is represented in a square box. B is also square, C and D and so on. So this means this is called a node. The node A, the node B, C and D. So this node represent, the square represent an activity. Okay? Okay, now. So now before you start drawing, you need to know some of the basic rules when you want to draw the diagram. So the first rule is the networks typically flow from left to right. That means when you start drawing the diagram, you have to start drawing all the boxes from your left hand side and then draw towards your right hand side. So the second one is an activity cannot begin until all of its activities are complete. So that means the second activity you cannot start until the previous, the predecessor, the one before, one or more than one activity before this current activity, if not yet completed, you cannot start the activity. So next, the arrows indicate precedence and flow and can cross over each other. So the arrow shows that which one comes first, then followed by which one. When you draw these arrows, you can crossing each other. Later, you will see some diagrams, then you will understand. Okay, next point. Identify each activity with a unique number. This number must be greater than its predecessors. So that means just now you can see is A, B, C followed by A, B, C, D. You see the later one, the successor one should be larger number than the previous one. So you cannot have the later number larger than the previous one. So that is an incorrect numbering system. So the later one should be greater than the previous numbering. Okay. Next, looping is not allowed. So this is a flow. It's just how say it's a flow chart. It's not a program flow chart. So your program flow chart, you may have if then else, do while, and that kind of condition. So that is inside there. You may looping. But this diagram here, no looping. You cannot do looping. So later I'll come to this point again. Next, conditional statements are not allowed. See, so that means loop inside there, the arrow go to each other, keep on looping inside loop. So conditional statement not allowed. You cannot have if then else. Okay, all this kind of programming statement. No, it's not don't have this kind of thing. No decision making. No conditional flow. No do while or while do something like that. Or case that kind of statement. Not such thing. Okay. So there's no conditional. Basically, that means you don't go and make decision. You just follow the flow only. So next, you use common start and stop nodes. That means you have one starting node and then one ending nodes. Okay, one common one. So even you have many projects ongoing, you start with one common one and you end with one common node. Okay, now you look at some examples to further explain just now what I've explained those terms. So these are called the fundamentals of this activity on node. So you can see, look at this diagram here. You can see the boxes here, A, B, C. So this is the activity A, activity B, and activity C. So A is preceded by nothing. In front of activity A, there's nothing. So you can start A. So B is preceded by A. So before B is activity A. So you cannot start B until A is completed. Next, you can C. C is preceded by B. So C cannot start until B is completed. So meaning C is dependent on A and B. Okay. So the next diagram, you can see Y and Z are preceded by X. So you can see both Y and Z. So before Y and Z, you can see the node X, the activity X. Y and Z, you cannot start until X is completed. So Y and Z can begin at the same time if you wish. So if you want to start doing the activity Y and Z together? Yes, you can, because they are not related. There's no arrow joining these two, okay? But make sure that X already completed, then only you can start activity Y and Z. Okay, next diagram here. You can see here the M, okay? So J, K, and L can all begin at the same time if you wish. They need not occur simultaneously. So J, K, and L are known as what kind of activities?
Merge activity.
No, JKL.
Parallel
activity.
Yes, good. They are parallel activities.
activity.
Yes, concurrent. So if you want to start together, you can. If you want to start together, also can. That means I start J first, later I start K and L together. Or I can start JKL together. So they are all known as parallel activities. So what is M known as? What kind of activity is M?
Merge.
Yes, that's right.
Merge.
JKL, all arrows going into M. So M is known as merge activities. Okay, merge activity. Inside there can have many WPs. But all JKL must be completed before M can begin. That's why M is called merge activity. You must have JKL completed, then M only can start. Okay, next diagram. So just now we explained, see the arrows can cross over. So you can see Z is preceded by X and Y. That means Z, you cannot start Z until you can see the arrow, the predecessor. That means X and Y are before Z. So you must finish both X and Y in order to start the Z. So same thing for AA. AA is preceded by X and Y. So AA cannot start until X and Y completed. So in this case, XY is known as what activity, and Z and AA is known as what activity?
XY burst.
Yes.
The A merge.
Yes, good. Okay, now you can differentiate. Okay, good. So all the arrows going in is known as merge. The arrows coming out, okay, no arrow attached with the box is burst. Okay, understand? Remember these two terms clearly. So this is very important to draw the network diagram. Okay, now we are going to start draw the network diagram now. So this is an example here. So this is called the automated warehouse ordering picking system. Okay, that's the name of the system. And these are the activities here, A, B, C, D until H. So this one is the name for each activity. The description A is known as define requirements, B is assign team, and so on. Okay, until H, which is integrate the systems. And next, you can see you are given preceding activity. So before activity A, there's no activity. That means A is the first activity. Then B, before B, you have to draw, that means A. A must be completed, then only you start B. Next is a C. Before C is A. So that's called preceding activity. Before that note, what is that note that must come before you can start that particular activity here? So before D is B, before E is C, before F is C, before G is D, and last one before H you can start will be you must finish E, F, G. Now, let's start drawing this diagram. Okay. So you can see here, this is the one that the info given. So this is A, so you draw A. Before, it says that before preceding A, there's none. That means you just draw this box here. A, this is not A or activity A. And then what's the name? It's called define requirements. Okay. Then followed by, you can see before B and C is AA. So then if start to draw arrow, that means before B is A, before C is A. So what is B? B is called assign team. C is called design hardware. Okay. So it's very easy. You just follow and then you draw. So this is the complete diagram for this part here. Okay, so you can see after A, you execute B and C. After B, then followed by D. You can see from here. After D, then you follow by G. Okay, then after A also you start C. After C, you start activity E and activity F. Then after that, the G, E, F together, then go into H. So in this diagram here, okay, question. Which one or which are the merge and burst activities?
AC bus.
AC bus. AC bus?
ANC.
ANC
Okay.
is burst.
Bus activities, yeah. Okay.
H is the merge activity.
Yes, that's right. Okay. A and C both are bus activities. And then H is the only merge activity in this diagram. Okay, good. Okay, next. Okay, now. So next we are going to start calculation. So what kind of calculation you are going to perform? So there are two types of computation. The first type is known as forward pass. The second type is called known as backward pass. So what's the purpose of doing forward pass calculation? So it's to find all the earliest times. That means after doing the forward pass, you're going to answer three questions. The first question is, how soon can the activity start? and also known as early start. The short form is ES. The second question is going to answer after you do this forward pass will be, how soon can the activity finish? It's called early finish. In short form is EF. The third question is, how soon can the project finish? Expected time is called ET. Okay, so after you have completed forward pass, the calculation, you can find the answer to these three questions, ES, EF, and ET. So after you finish the forward pass, then you're going to do a backward pass calculation. So purpose of backward pass calculation is to find the latest times, all the latest time that you need to know. So you will answer these four questions here. How late can the activity start? So it's called late start. In short form is LS. Then is how late can the activity finish? It's called late finish, LF. And then you also can answer the question, which activities represent the critical path? Which one is the longest duration? That's the critical path. And then how long can it be delayed? Can you delay any of the activities? So that one is based on, you will calculate the slack or call it the float. In short form is SL. So backward pass, you are able to find the answers to these four questions here. So we're going to start doing the calculation now. Okay, so this one is the previous one given. Now you got the one extra column here, which is the active time, so that you can calculate the forward pass and the backward pass. So now activity A is given 10 work days. So in days, working days, 10 working days. Activity B will need 5 working days. And then C, 25, 20, 50, and so on, until H is 15 working days. Okay. So now how do you draw? So you can draw your diagram, network diagram in this format, or you can draw a 9 cube. Inside the big box, you got the 9 small cube here. So you can draw this way. So just now you mentioned A is activity, and the name of this activity is called defined requirements. So what is the duration here? Okay, so you can see the duration here is 10 work days. So you put here. So you can see the legend here, right? You can see the legend here. You can see this legend here. The center box is called duration. DUR, it means duration. How long it takes for the activity to finish. So you can see the legend here. ES is this corner. Then ID, EF. Then SL, the description. And then the last row here is LS, duration. And then the late finish. So you can see the first row is all the early thing. The last row will be all the latest one. Okay, the center is the stack, the free time you can have. So now you just put in the values only. It's very easy. So just how you already plotted this. Now you change to these boxes form. Inside there got small cube. So you have this B, C, D, E, F, G, and H. And now you only need to add in the duration, which is given from this column here. 10, 5, 25, 20, 50, 15, 35, and 15. Just fill in the box duration. Okay. So next we can proceed now doing the forward pass. Okay, so how you do the calculation of forward pass? So you take note of this statement here, the 3 statements, very important. You add the activity times along each path in the network. How do you add? You add ES plus the duration will give you EF. Okay, then you carry the early finish, this EF, to the next activity where it becomes its early start, the ES. So the first you ES plus duration becomes EF. This EF will bring to the next box becomes the ES of the next box. And then, but unless the next succeeding activity is a merge activity. So remember, you see just now we learned the term, if it is merge activity, in which case you have to take the largest EF of all the preceding activities. You have to select that one. So you compare all the values that are coming in, because it's merge, many arrows coming in. You choose that arrow that ending with the largest number and become the ES. Okay, if it is a merge activity. So now let's start. So you can see you already put in just now all the value and we start the calculation of forward pass. So how do you do? ES plus duration equals to ES plus duration equals to EF. So it's a V shape. Here add to this become this V, the letter V shape. So you use 0 plus 10 give you 10 here. So remember the second statement say the EF of this activity becomes the ES of the next node. So the 10 here, the EF becomes the ES. So put here and put here. So you have to check the node here. Is it a merge or is not a merge? This is not merge. So you just put the value only. Okay. Only when merge, you have to take note and take the biggest value. So that this is not merge. So you just put the 10 here plus 5 equals to 15. And this one put the 10 become here for the node C. 10 plus 25 becomes 35. So we continue from previous one B here. B go to the next node which is D. So you can see this is also not a merge activity. So this EF becomes the ES. So bring 15 over to here. Then V shape again. 15 plus 20 becomes 35. So next, come to C here. C here ending with 10 plus 25 is 35. So now the next node is E here. So this is also not merge activity. So being EF become the ES. Then 35 plus 50 becomes 85. And here C go to F. So again, this one is also not merged. So 35 bring here become 35. 35 plus 15 becomes 50, right? So here come to D go to G. This is also not merged, just bring EF to the next node, which is the ES. So 35 plus 35 becomes 70. And then this one here, 85, you go here, but don't do anything first. So you write, you can see this value, 70, you just bring this small value at the end of this, before this arrow here. 80, just 85 before you bring the value here, and 50 you bring the value here, because the H is a merge activity. So remember the statement says, if this is a merge activity, whatever values coming before it, the predecessor, so you write down the value and need to compare, and you must take the biggest value, the largest of these three values. So in this case, the largest value is 85. So 85 plus 15 becomes 100. So can anyone tell me why you must take the largest? What is the largest?
Because merge activity has to wait every activity proceed to finish first.
Yes, that's the correct answer. So because H is merge activity, that means H cannot start until all the predecessors, all the activities before H must be completed. So if you take the smaller 70, you cannot, because this one is not yet completed, only these two completed. So that means H still cannot start until E completed. So that's the reason why you choose the largest. You have to compare. So that's why the best practices is always write, you can see this is the merge activity, always write the values at just before the ending of this arrow here, then you can make comparison. Otherwise, you will miss some value and then you simply put 70 or put 50 here. You understand? So you must do this so that it guide you that you will come to merge, you choose the largest and not the smallest, or which is the middle value or what. You understand now? Okay, good. So now you understand why you choose the largest, because H cannot start until all the predecessors, all those before this H activity completed. That is the largest value. Okay, largest duration you need to, the time taken to finish all by all the three activities. So now this is called forward pass. So is that okay? Understand how to do? No problem, right? If no problem, okay, now do the question here. This one just require you to draw the project network. No duration yet. Just want to teach you how to draw the dependencies, okay, and whether you can draw it correctly. Okay, I give you 2 minutes. So everyone take out a piece of paper and start drawing. So learn how to draw it, do it step by step. Finish drawing? All finish?
No, haven't, doctor.
Okay, okay. So give you some more time. Give you another minute. Finish now?
Yes, doctor.
Okay,
Yes,
so
doctor.
yeah, good. Now you compare your answer with my answer, right? Do you get this? Yes or no?
Yes.
Yes, doctor.
Okay, good.
Yes, doctor.
Okay, good. So now
Yes,
you
doctor.
have to know how to draw the interdependency. Which one comes first, followed by which one, and which one is the burst, which one is the merge. So in this diagram, which are the burst and which are the merge? Burst, which are the activities are burst.
E, B, F.
A,
B,
Yes, that's right. F. Which are the merge activities?
G, J, K.
G, J, A.
Yes. Okay, now you understand very well. Good. Okay, let's proceed. Okay, now after okay, now you continue with second question. Now you do this one. Now this one with the duration. So given the following project information, first same thing, you draw a project network for the project. So you draw just now, then you can draw with the 9 cube inside the big box, or just now the example there. Okay, and then you compute the early activity times. This time you're going to do the forward pass. Okay, so make sure you understand how to do first before we do the backward pass. So I give you 3 minutes. Have you finished drawing the project network, just the first part? Finish the first part? Yes? Yeah, let's see. First part. Okay, do you get this?
Yes.
Okay, good.
Yes.
Now you do the forward pass. Finish? Finish or not?
Yeah, yes, doctor.
Okay. What is the ending? What is the EF for H?
I got
45.
45.
45.
What's the value?
45.
35. Okay, let's see.
45.
45.
45.
45.
45. You compare your answer.
45.
Okay, with my answers. Okay, you get this?
Yes.
Yes. So you know,
Yes.
0 plus 2 is 2. You bring all the 2 here. 2 plus 15 is 17. 2 plus 10 is 12. 2 plus 13 is 15. 2 plus 18, 20. So next, you can see this one is not merged. This one is merged. So you have the B and the F. So we go to do this one first. So C and D go into F is merged. So you bring the 12 and bring the 15 here. So remember to take the largest value. So you put 15. So 15 plus 15 is 30. And this G is merged. So you put the 17 and 30 here. You compare the largest is 30. So you put 30 here. So 30 plus 10 is 40 here. And this one is 20. Straight away go to here it will be 20. But this is merged. So compare 40 and 20. Largest is 40. So 40 plus 5 becomes 45. Understand? Okay?
Yeah.
Okay, anyone don't understand? So you know you must do the forward pass correctly, otherwise your backward pass, everything will be wrong. Okay, so next we are going to learn the backward pass. Now, the backward pass, these are the 3 statements you have to take note. So how you do the calculation of backward pass? You subtract activity times along each path in the network. So what's the formula? You use LF minus the duration, you get the LS. And then you carry this, the late start, the LS to the next, that means the next activity where it becomes is late finish. The LS becomes the LF unless, okay, the next succeeding activity is a burst activity, in which case you take this time is the smallest LF of all the preceding activities is selected. So remember, you going forward, you will be having the merge activity, then you remember to take the largest. And then when you're coming backward, it's because of the reverse. So that's why you forward is largest, backward you take the smallest. So forward you plus, then backward you use minus. You understand? Okay, so now let's do the backward pass. So remember just now you're ending this forward pass, you're ending with 100. So you bring down the 100 to here, this place, and then we start do the calculation, okay? Now, so you bring down the 100, and then 100, you minus 15, you get 85. So you go back, this value LS become the LF of the preceding one. That means this 85 become the previous one here, okay? The LS of this last node H become the LF of G, E, and then F. So you just put this to here, put this one to here, put this to here. Of course, you check whether this is a burst or not burst. If burst, then you must take the smallest value. So this is all not burst, so you just put 85, 85, 85 here. Then you go back again, so go backward pass calculation, 85 minus 35, you get 50. So 85 minus 50, you get 35. 85 minus 15, you get 70. Okay, so this one go back, this become this one here. So because it's not burst, just put the value here, copy over here, 50 over 50 here. So 50 minus 20 is 30. So same thing, this one is not burst, 30 bring over here. 30 minus 5 becomes 25. So we finish there. So this one here, 35 here. So you can see this, the one before this, the preceding of this E and H, F is C. But C is what? A burst activity. So remember, just put again like the merge activity, you put the value here first. And this is 70, put the value here, and then you compare. So between this 35 and 70, remember you are going backward. So backward, you must take the smallest. So which one is smallest? 35. So you put the 35 here instead of 70 here, because you got 2 values. Going backward, take the smaller. Going forward, merge, you take the largest. So you put 35 here, minus 25, you get 10. So again, you can see the A is a burst activity. So you put the 25 here, you put the 10 here. Now you compare. Which one is the smallest? 10 is the smallest. You put the 10 here. 10 minus 10 equals to 0. So this is the way to do backward pass. So remember, forward pass, V shape. You just take the ES plus duration becomes EF. Then you go to the next one, just bring your EF become the ES. Unless merge activity, remember to take the largest. So coming backward, you just take LF minus duration equal LS. And then ls becomes the next one, the succeeding node. You go backward, and then just ls become the lf. So if it is the burst, then remember to take the smallest value. That's it. You understand now? Okay, let's continue. Okay, so next is you have to determine the free slack, or we call it the float, another term. So what is the meaning of slack or float? So this one determines which activities can be delayed. That means along all this path here, there are some activities that you got a slack, that means got some free time. So if you cannot start on that day, you can delay. And if you delay, you don't delay the project duration. You still can meet the deadline. So these are known the slack or called the float. So next, what is the meaning of total slack or TS or SL? So total slack, in short form SL, is the amount of time an activity can be delayed and not delay the project. So that's why I explained. You delay the activity. So activity is supposed to start now, but you don't start. You start 2 days later, but you still never delay the project duration. So that's called you are having a slack. So TS is the amount of time an activity can exceed its early finish date, the EF, without affecting the project end date or an imposed completion date. So how to calculate this SL? So the formula for SL is equals to LS minus ES, or SL is equals to LF minus EF. Either one, you get the same answer usually. But sometimes if you minus, the two values could be different, okay? So you just put, okay, just use the two formulas here. So there's one more term is called free slack. So the short form is FS. So this is the amount of time an activity can be delayed after the start of a longer parallel activity or activities. So this FS shows you how long an activity can exceed its early finish date without affecting the early start dates of any successors. And this FS allows flexibility in scheduling the scarce resources. Any resource not enough, you look at which activity you can delay, you delay that one, and then you let the activity that require that resources that needed urgently, you use for the activity first. So the one that can delay, you don't go to assign the resources first. So the formula for counting FS is equals to ES minus EF. The next ES minus the front EF. Okay, now let's have a look at this diagram here. Before that, there's one more term called sensitivity. Sensitivity means the likelihood the original critical path will change once the project is initiated. That means you later, after you finish forward pass, backward pass, and then you calculated the slack. After the project started. So this critical path is the network path that has or have the least slack in common. So how to calculate, how to know which is the critical path? That means
Doctor, I cannot hear you.
for this each node you do the same. 0 minus 0, 0. 10 minus 10 is 0. It's the same one. 25 minus 10 is 15. 30 minus 15 is 15. So 10 minus 10, 0. 35 minus 35, 0. So 30 minus 15 is 15. 50 minus 35 is also 15. So 35 minus 35, 0. 85 minus 85, 0. 70 minus 35, 35. 85 minus 50 is 35. So here 50 minus 35, 15. 85 minus 70 is also 15. So you can see this is the way to calculate SL. So what's the critical path? Remember, critical path says the SL is the minimum value. So in this case, you just look for 0, 0, 0, 0 here. So which one is critical path? You see the dotted line. So it's the critical path will be A, go to C, go to E, go to H. You understand now? So A, the path of A go to C, go to E, go to H is known as the critical path. That means you got a slack of 0, which means the activity A, C, E, and H you cannot delay. If you delay any of these activities, the duration will be exceeding 100 work days. Okay, you understand now? So that path is known as critical path. So what is FS? The free slack. Free slack just now given the formula is the ES. Okay, this the next node minus the EF of the previous node. So the 15 minus 15 is FS equals to 0. And this one 35 minus 35 is 0. Okay. And this one 85 minus 70 is 15. So the rest you can see the same. 10 minus 10 Fs is 0. 35 minus 35 Fs is 0. 85 minus 85 Fs is 0. And 85 minus 50 here, Fs is 35. So this means the free set means you can delay. You see all this along this path here, this activity, if you delay 15 days, you just nice, you can just meet the time to start this activity each. Okay, understand? So that is called free slack. Free slack is the next one, ES minus the previous EF. But the slack is the lowest, the LS minus ES or LF minus EF. Okay, so you know the differentiate the two now. Okay, now let's proceed with the calculation. Okay, continue with just now the question 2. Now you do the backward pass. And then you find the slack, the SL. After that, you identify the critical path. So there are 3 things here. So you start doing now. So I give you 3 minutes. Finish with backward pass. Yes.
Yes.
Okay, let's compare your answer with the backward pass first. So whether you get the right answer. Do you get this?
Yes.
Okay, good. So now you calculate the slack. Very easy. Just LS minus ES or LF minus EF. Finish? Finish SL?
Yes,
Yes.
doctor.
Okay, let's compare your answers with my answer. Do you get this?
Yeah.
Yes.
Okay, good. So what is the critical path?
A, D, F, G, H.
EFG?
A, D, F, G, H.
ADFG.
Yes. ADFG and then?
H.
H.
Yes.
H.
ADFG. You must not miss the H, okay? So ADFGH. You cannot be hanging halfway, right? Understand? Okay. So you must from the starting note until the ending note. Okay, all of you got the answers here? Same as mine?
Yes, doctor.
Yes or no?
Yes.
Okay, good. You have to know how to do this, because as I mentioned, in my test too, you need to know something like this, right? Okay. So no question, we'll proceed. Okay, now, just now I mentioned the network logic errors. So this network logic error, one of it is just now said you cannot have looping. So later I will show you the diagram. Next is about activity numbering. So remember your numbering, the later one must be larger than the previous numbering. So it's not necessary you use A, B, C, D, E. So you can have A then followed by G. So in case when you're drawing a network diagram, so you miss some activities in between. So it's better you have A, let's say G, and then let's say is M, you know. So in between, if you later want to add another node, then you can just insert without having to changing the latest node, you see, because A to G, then in between got some number B, C, D, F, and so on, you can add. So if you want to add another node in between, so it's good to have the later value is larger than previous and not necessarily must be the next number. So it can be used 1, 2, 3, 4, 5. You can use A, B, C, D, E, or you can combination of number or alphabet. You can. It's up to you for your numbering, which has meaning to you. So next, the use of computers to develop networks. So later I'll show you 2 slides using computer to plot this network activity diagram. And next issue is about calendar dates. So that means you have to define your calculation of this duration. Is it in days? Is it in weeks? And then you have to, if you use computer to plot, then you have to minus those public holidays and then those weekends that you don't work and only based on the working days. And last issue is about multiple starts and multiple projects. So in a company, you are doing many projects ongoing. So you can draw, of course, one network diagram for each project. But if you combine all the projects together, then you have many projects. They may not start at the same time. But just now we mentioned, preferably you have one unique start and one node of starting node, one node of ending node. So that is using a dummy starting node and a dummy ending node to represent one starting point and one ending point for multiple projects. Okay, so let's look at this one, the network logic error. So you cannot have this kind of diagram. So if your network diagram A go to B, B go to C, C go back to A, this is called looping. So in network diagram, you cannot have this kind of diagram. So that means that is a wrong network diagram. You have to just go straight all the arrow going towards from the starting until the end and finish. You cannot look back, okay? So this is an incorrect network diagram. So this is a diagram that shows that can be plotted, network diagram can be plotted using computer software. So in this case, the software shows you the name of the activity, then when's the starting date and what's the ID. So in this case, the ID here is 2, 3, 4, and then follow is in sequence 5, 6, 7, 8, and 9. And then when is the finishing date and what is the duration is 10 days. And the RES here means the person responsible. That means you assign who is the owner. Remember your responsibility metric, the R, the name of the R will be put here, right? So this is a one type of software that can help you to plot the network diagram in this format. So you can see from here, which one is the critical path. So it's shown in this, you can see the color here, which is in blue. You can see from 2 go to 4, go to 6, go to 9. That means this path is a critical path. Okay, understand? So this is plotted by using a software. So next one is plotted by, I think some of you already learned Microsoft project, okay, the scheduling one, the software. So you can learn MS project here easily and you will plot this in terms of the Gantt chart. So you can see this is the duration, this is the name of the task or the activity name, the starting date, the finishing date, then you have the late start, when is the latest date for you to start, the latest date for you to finish, and then you will calculate the free slack for you, your FS, and this is the total slack, the SL for you. So this one is the Gantt chart here, okay, in the bar form. So this is the duration, which is the duration here, which is 10 days. So you start from here, and you can see the arrow coming down. If the one that having this one here, it means you got a slack here. Okay, so which one is your critical path? You see this one, all the 0, 1. This one is the critical activity. So the gray one going down all the way down, no extension line. That means these are critical path. They have no slack. So here all the gray one shows this one coming to here, to here, to here. These are the activities that is known as the critical activities. Understand? Okay, so this is another type using Microsoft Project to plot your Gantt chart and to show the network diagram. Okay, so the next one, okay, another some of the issues about in real life situation. So this is known as the extended network techniques to come close to reality. So the term is called laddering, ladder. So activities are broken into segments so the following activity can begin sooner and not delay the work. So we don't go and say you finish activity A, you finish only, you start activity B, and then finish B, then you start C. We don't do that in real life. So we do laddering. You can start breaking down a very long duration activities into segments, into a few parts. And you can start straight away and not waiting for that long one to finish, then only to start the following one. So here in this case, you will apply something called lags, L-A-G-S, lags. So what's the difference? So with the slack. So this is called the minimum amount of time a dependent activity must be delayed to begin or end. That means you are forced to delay. You stop waiting. You're waiting time for your start or waiting for a certain time until you finish it. So that's called lags. So lengthy activities are broken down to reduce the delay in the start of successor activity. So just as I mentioned, if very long duration activity, you break it down into a segment, and then you can start together. Okay. So lags can be used to constrain, finish to start, start to start, finish to finish, start to finish, or combination of relationships. So what do you mean by this? So let's see, look at some diagrams here to understand this. Now this is an example of laddering using finish to start relationship. How do you know? How do you read? So you see the arrow is starting. So let's say, I'm sure you always see, the Shabas. Sometimes they will repair, got a pipe, water pipe burst. Then they'll repair some of the pipe and then they have to dig, and then take out and replace the pipe. So you can see they're digging trench. You see, so they dig the sand or the soil and then they take out, replace the pipe. So let's say you're replacing the pipe now. So you trench a bit, you dig a bit, and then you start digging the next 1/3, the second 1/3, you can start laying the pipe inside. So next you trench the third 1/3, another 1/3. At the same time, you lay the pipe. At the same time, you fill back the sand to cover back the pipe. So you can do this, you break down, you see, in 1/3, 1/3. And then when you finish already, this one will lay the pipe. So this one go lay the pipe and then you go to refill. So this part refill already finished the first 1/3. And the last part, you fill the second 1/3 and then the last 1/3. So you can do it in parallel. Some activity you break it down. Not say you trench the whole thing, let's say 1 meter long or 1 mile long. Then you start putting all the pipes together, then you fill all the sand. So you can do a bit and then the second task start and then you do the third start at the same time. All the 3 can be 2 or 3 can be in parallel. Okay, so this is the real life situation and this way is called the laddering. So how do you know what's the term called finish to start? How do you know this is called finish to start? So you see this is the box. The ending line here, this is the finishing of this activity here, trenching the sand here, dig the hole. Then this is 1/3. After you finish this, then you see the arrow go here and you start this, the trench and also the lay the pipe. So this is the starting point of the box, starting point. This is ending. So this is called finish to start. Finish the previous activity and you start the new activity. So this is called finish to start relationship. Okay, you know how to read the arrows. Okay, now let's how to read the next one. So this is called finish to start relationship. So you have the 2 activities here, X and Y. So you finish the X, then you start Y. But you cannot start immediately after X completed. You have to, you see the lag 2. So let's say the time unit of measurement, let's say we use days. So lag 2 means you have to wait for 2 days later. So Y can start after X completed, but 2 days after completion of X. So that's called lag 2. Okay, so if this is weeks, that means you wait until 2 weeks later after X completed, then only you can start Y. Okay, understand? So this is called finish. This is finishing point. This is starting point. So it's called finish to start relationship. So now you look at this diagram here, start to start relationship. So the first box here, A, you can see activity M and activity N. So this is the starting point of M. This is also starting point of N. So you can see the arrow is from the starting of M go to starting of N. So this is called start to start. So that's why when you draw the arrow in your network diagram, make sure you draw it correctly. So if this is start to start, make sure you draw from the start, go arrow to the start. Then this is known as start to start. So in this diagram, it means the moment you finish activity, the moment you start activity M, because it's start, then it start. The moment you start activity M, you also start activity N. So that's called start to start without any delay. So in the diagram B box here, you can see activity P and then activity Q. So here you can see the arrow also is start, go to the start. But here you can see the phrase here called lag 5. So let's say this is 5 days, right? So meaning activity P started, 5 days later, you also start activity Q. Okay, so that's the meaning of lag. So this one is you start together. Activity M started, activity N also started. But this one means activity P started, but 5 days later after the starting of P, then only you start activity Q. Okay, so that's the meaning of start to start relationship with lag. Okay. Next, just now that diagram, the diagram that shows the trench, the laying pipe and the refill. So you can interpret just now that diagram using these legs. So use legs or reduce the detail. So instead of just now you draw that kind of diagram, looks very complicated, you reduce that diagram, become this format. So you do the trench of 1 mile, then you see you start, let's say assuming it's 3 days later, leg 3, then you also start laying the pipe, okay, for 1 mile. And then after you finish, you start doing the laying the pipe 1 mile. Let's say 3 days later, you can do the refill after put back the sand, cover the whole 1 mile after 3 days later. You understand now? Okay, so this is the interpretation of legs. And then the relationship in this case is start to start with legs of 3. Start to start with leg of 3 here. Okay, so you must know how to read the diagram and how to interpret, and you must draw it correctly. Okay, now this is another diagram to show the laddering. Okay, the legs. Here is not given the legs, but it's the laddering here. So you see the normal traditional sequential approach. You start, let's say this is the phases. Okay, you have product planning followed by systems engineering, followed by engineering design and development, and then procurement, and then manufacturing and production and quality assurance, and then you release. So you can see this one means what? The relationship is what? Finish to start. Finish to start. So meaning you finish only this phase, only start the next phase. Or finish this activity, then you start this activity. So it's long time. Excuse me. So now you're using laddering. So you can see it's start to start. So you started product planning, you also start systems engineering. The moment you start system engineering, you also start engineering design and development. So you see if you apply laddering, then you can see the duration is shorter. So if you do finish to the start to finish or finish to start, then it takes longer duration. If you do laddering, your duration to finish this all the activities is shorter. Okay, so that's why in real life we don't do this kind of things. We don't do finish to start. We will do start to start in parallel. Okay, and cut short the duration to finish your activities. Okay, next we look at the use of legs, the different types of relationships. So this diagram shows you called finish to finish relationship. How do you read? So this one is, let's say, is building a prototype. Then this one is testing the prototype. So just now the term is see finish to finish. The ending of the box is the finishing point. The ending of this box is the finishing point. So you see it's from the finishing go to finishing. So that's why it's called finish to finish relationship. So with the lag of what? So assuming this is weeks. So this one means the finish building the prototype, then 4 weeks later, after finish this prototype, I also finish testing. So that's called finish to finish. Next one is called start to finish relationship. So you see this is the box here testing. This one is starting point. This one is ending point. So it's called start to finish. So the testing started, and then let's say 3 weeks, like 3 weeks, okay, like 3 weeks later, I started 3 weeks later of testing. I also finished system documentation. Okay, this diagram here shows combination of the relationship. Okay, so here you can see the coding started. 2 weeks later, I started debugging. So the coding finished, and then 4 weeks later, I finished coding. I also finished debugging. Okay, so you know how to read the diagram now? Okay now? Is that clear? So make sure that if finish, then must be ending of the box. If you see the word start means starting of the box, don't draw in the center. You understand? Don't draw anywhere. Only starting and the finishing point. Then you won't get mixed up. Okay, now you come to this, the network diagram, come back to reality. So we use lex in our real life situation. So how to apply lex here? So now assuming that these are the activities here, got the A, B, C, D, E, and F. So applying the this lex here, so you can see this diagram, the A started and then you have like 3. So let's say this is days. 3 days later, A started. I also started B 3 days later. Okay, so now A, we do the, you see, these are the duration 5, 1, 2, and then you got 3, 2, 6 here. So this arrow shows A started 3 days later, B started. So 0, this 0 here, this one, plus 3 equals to this 3 here. So using V-shaped forward pass, 0 plus 5 equals to 5, right? So 5 you bring over here is 5 because it's only one activity, not merged. So just put the 5 here. 5 plus 3 is supposed to be 8, but it's 20. Let's see how you get this, okay? So now we come back to here. 0 plus this 3 gives you 3. 3 plus 1, it gives you 4 here, the V shape. Then you see there's a leg 4 here means finish. What is the relationship? Finish to start. So 4, this one finished. 4 days later, I start this one. So it's 4 plus 4 equals to 8. Okay, then V shape. 8 plus 2 equals to 10. Now come to here. Here being to here supposed to be 10. You see, this one is a merge. So this is 5. So 5 being to here is 5 here. You compare 5 and 10. Remember, merge activity, you must take the largest. So between the two, you take 10. So you put 10 here. 10 plus 6 equals to 16. So now you look at this relationship. Is start to start. So this one started. 2 days later, this E also started. So 10 plus 2 equals to 12. 12 plus 2 equals to supposed to be 14, but it's 18. So how you get this? So this one 10 plus 6 is 16. So you see this relationship is what? Finish to finish. So that means I finished this activity D, then I also 2 days later, I finished activity E. So 16 plus 2 becomes 18. So that's why instead of 12 plus 2 is 14, becomes 16 plus 2 is 18. So going forward, always take the largest. Understand? Now you look at this relationship here. This one is finish to finish. So 18 plus 2 is become 20. So that's why just now is 5 plus 3 is supposed to be 8, but it's not. It's replaced overruled by 18 plus 2 is 20 here. Okay, do you understand now? How to look at, how to apply lex and how to look at the relationship, okay? So now this is forward pass finish. Now you do the backward pass. It's the same thing, okay? So here you take 20, you put 20 here. 20 minus 3 is 17, right? Okay? So now you're supposed to bring the 17 over here, right? But this one, remember, is a burst. So you have to compare value, okay? Next, okay, come back here. Now, this one come back here is here, okay? This one is 20, so you minus 2 becomes 18. 18 minus 2 becomes 16, okay? So remember this one, you see, the moment you started, this one started. So this one 16 minus 2 supposed to be 14, but so you take this one, come back here first. 18 bring here minus 2 is 16. 16 minus 6 is 10. So you take the smallest, you understand? Okay, then after that, this one go back here, 10 go back here because it's not burst, just put 10. 10 minus 2 is 8. So this one coming here is supposed to be, this one is 8 here, 8, then you see a leg again. Back 4, then you minus back. So 8 minus 4 is 4. 4 minus 1 is 3. So just now you put here supposed to be 17. Why I put a 12? Maybe I typed wrongly. Okay, this one should be 17 here. Okay, not a 12. Why I put a 12? You see from here? Let me see. 12 minus, no, this one is 12. Okay, this one I typed wrongly. This one should be 12. This one should be 12. It's from the 17 here. Okay. Not 12, 17. Right? Okay. Okay, so this one bring back should be this one here, right? So this one is come all the way from here, this 10 and this one here. So between 17 and 10, you take the smaller, so it's 10. So 10 minus 5 is, 10 minus 5 is supposed to be 5. But you see, 3 minus this one is 3. Minus the leg 3 here becomes 0. You understand? So between this 5 and 0, you take the 0 here. Okay, understand? So that is the backward pass. Now you calculate the slack. So 0 minus 0, 0. 10 minus 5 is 5. 3 minus 3 is 0. 4 minus 4, 0. 8 minus 8, 0. 10 minus 10, 0. 10 minus 10, 0. 16 minus 16, 0. 16 minus 12 is 4. 18 minus here, you can see the value is different here. The LS of minus the ES here, this value here, the early one and the late one is different. One is 4, one is 0. So meaning this one got slack, but this one, the late finish here, this side you don't have. So this one 17 minus the 5, you got 12. And then the 20 minus 20 is 0. Okay, so not necessarily both 0, 0 or both 12, 12. Okay, understand? So this is after applying the legs. So you can see you don't go and adjust the value. Just do the same format using the same formula, forward pass, backward pass, but with the consideration of the legs and looking at the relationship, whether start to start, start to finish, finish to finish, and so on, or combination of all the different types of relationship to do the calculation carefully. Okay, so this one will be a little bit complicated, but you need to be more careful, right? Understand? Any questions so far for this legs? A bit complicated now. Okay, next one more term is called hammock activities. So what is the hammock activity? So this hammock activity spans over a segment of a project. That means within the duration, I only want to look at certain part within the path. So it has a duration that is determined after the network plan is drawn. So after you finish drawing, then you decide which part you want to focus. It's used to aggregate sections of the project to facilitate getting the right amount of detail for specific sections of a project. I only want to focus certain section, I'm very concerned. Other section, I'm not so concerned. So within that section is called hammock activity. It's very useful in assigning and controlling indirect project costs. So that means when I want to assign a certain resources not enough, then I want to know within that part, how long it takes going to use that resources or that amount of money that I need, the cash flow. So now you look at this example here about hammock activity. So now you have this activity A.
Sorry.
Yes.
Doctor,
Yeah.
I think you are not in presentation mode.
I'm not in the presentation mode.
Yeah.
Okay. Just now, I mean, you missed all the things just now I explained.
Just now we missed the hammock activity.
Hammock. Okay. Okay. Let me. Can see now? Can see the slide now?
We can see the slide, but it's not in presentation mode.
Not in presentation, is it?
Slideshow.
Okay. Is it slideshow now?
No. Yes.
Okay. Okay, sorry. Because I have to tell me, but I don't know what you see from your side. Okay. So always you can interrupt. Okay. So this one hammock activity here. So you can have A go to B, and then you can C followed by CD, and then E, F, and then H. So hammock is along this path here. I only want to focus certain section. So I want to know within this section, let's say certain resources will be needed for how long. So how do you do this? So you only need to take, okay, this one is the duration 5, 1, 5, 4, 10, 3, and 4. So here the duration for A is 5. So it's just, you know, do the forward pass. 0 plus 5 is 5. 5 bring over here. 5 plus 1 is 6. Then 6 bring over here. 6 plus 5, 11. Then 6 plus 4 is 10. So this one is just all forward, very straightforward, no merge activity. So 11 to 11, 11 plus 10 is 21. 10 bring over here 10. 10 plus 3 is 13. So 13 bring over here supposed to be 13, but you can see this one, there's a value. This is called the merge activities. So this is 21 here. This one is 13. So actually, I prefer the arrow go here. Otherwise, you see, you'll miss this 21 here, understand? Or else you put the 21 here and then the 13 here. So you compare between 21 and 13, you put the largest one, which is 21. 21 plus 4 is 25. So that is forward pass. So backward pass, you bring down 25. Then minus 4 is 21. So 21 bring over here. Then 21 minus 3, then you got 18. 21 bring here. 21 minus 10, 11. 11 bring over here. 11 minus 5 is 6. 18 bring over here. 18 minus 4, 14. And then here, 14 and 6, you compare. This one is the burst activity. So you take the 6. 6 minus 1 is 5. Right? So 5 bring over here. 5 minus 5 is 0. So that's the backward pass. So the slack will be this value minus this is 0. This minus this, 5 minus 5 is 0. 6 minus 6 is 0. 14 minus 6 is 8. 18 minus 10 is 8. 11 minus 11, 0. 21 minus 21, 0. So you have done the forward pass, backward pass. So the Hammock activity is, I only want to focus within this path here. The dotted line will be the critical path. You see all the 0. So A go to B, go to C, go to E, go to H will be critical path. You see the dotted line here. So I want to know, management is saying, okay, I'm very focused. I want to know within this period, there's certain resources you needed to use. And that will be how long? So how to calculate Hammock activity? Just take the ES from here, put into this box. And this is labeled called G, and this is called the Hammock activity G. And you just take the EF here. This is the ES. This is the EF of the last activity of the node that I want to know. Put here. And then 13 minus 5 equals to 8. So that means the Hammock activity is the duration of 8 days. Okay, so this part, I only want to focus certain part. You only take you draw this box, take this ES value put here, and take the EF value put here, and put the duration here. That's all. Okay, understand the term called Hammock activity. Okay, so now we do another question. So to make sure that you understand how to apply legs and how to draw the diagram with the legs, different types of relationship. So make sure that you know how to do this. Okay, can start now. So I give you some time. You do it part by part. So given the following information, you draw the project network AON first. That's the first step. Next, you compute the early, late, and slack time for the project network and then identify critical path. So first one, you draw the diagram, dependency, all the boxes with 9 cubes inside. And also take note of this relationship. I see how you draw this. It's a bit complicated now, but you learn how to draw this correctly. Then after you have done this, then only you proceed with forward pass, then backward pass, and then you find the slack, and then find critical path. So we'll do it step by step. So I give you some time to start first. So I give you 5 minutes because it's a bit complicated for the first part. Once 5 minutes over, I'll show you with my project network. I show my answer, and then you just compare, see whether you get the diagram correctly. Then after that, you proceed with forward pass and backward pass. Okay? So can start now. finish with the project network diagram AON? Finish? First part. Is it done with the relationship additional leg? Yes or no? No answer, not yet. Finish now. You check your answer with my answer first before you proceed with the forward pass. Anyone finish already? Finish? Anyone finish? First one? The project network AON? Yes?
Yes, yes.
Yes.
Okay. Yeah, you compare your answer with my answer first. Here, draw the project network diagram. So do you have get this? Is it same as mine?
Yes,
Yes.
Doctor.
Okay, good. So from now, you start doing the forward pass. Compute the early, late, and slack time. So do the first one first. Compute the early first, forward pass. Finish with forward pass. Anyone already finish forward pass? Yes or no?
Yes.
Yes,
So you
Doctor.
want to check with my answers?
Yeah.
Yeah.
Something wrong. Can you see the slide?
Yes. We can see the slide.
Okay. Let me show you the answer. Okay. You get 57? You get ending 57? Yes or no?
Yes.
Okay. So now you do the backward pass. Finish with backward pass. Yes. Anyone? Anyone got problem with the forward pass? You don't understand, you can ask me now.
Yeah, Doctor, may I know why for the the start?
Okay. You don't understand the forward pass?
Yeah,
Okay.
the
Let
earlier
me
start.
go through it. Okay. You can draw the diagram correctly, all the dependency and the lag. Is that okay?
Yeah.
You got problem with, first you have to plot this network diagram. Do you have any issue on plotting this diagram first? The A, B, C, D, the plotting of dependency, all the arrows. Do you have any issue there?
I am a bit confused about the lab 5 and then.
Okay. I think I teach you how to draw the diagram. Okay. Yeah. So I just go through step by step. You better ask me now. Okay. Okay. Let me go back first. How you get to, okay, how you get to you have this picture, right? Maybe can you capture first on your handphone or something, because I'm going to next screen now, you cannot see. Is that okay? Can you capture your camera with the handphone first? Then
Yes.
later, because the next screen I don't have this value already, then I'll be on the screen showing the flow. So you capture first, then after that you can refer from your handphone. Is that okay?
Yeah, okay.
Okay, now I go to next screen. I will start drawing this. So you can see all the duration given, and then you have you see this part here, finish to start predecessor. That means from the front, the finish to start to the next node got any of this dependency here, right? And then this one is finish to start, like that means you got any of this. Okay, if got, then there will be value given here. So this one is additional one. So you draw all these things first, then only draw the additional, and then with the legs of this. So how to draw? So first thing you need to know how to draw it. Okay, let's see. So you refer to just now the table. We start it one by one. Let me look at my camera also. Just a minute. Let me look at my chart. Okay. So your first one, you start with A, right? No problem, right? You start with A, and in front of A is none, right? So only A, the duration is 2. Is that okay?
Yeah, okay.
Okay. So next one, you come to B. So the table there shows in front of B is A, right? Am I right? In front of B is A. Okay, you draw this. In front of C is also A, right? In front of D is also A. Is that okay with the B, C, D?
Yes.
Okay, so now, so you finish. There's nothing there. You see, B, C, D, you can see all finish to start, like that means the A finish to start is all 0, 0. So there's no value in front here. Is that okay now?
Yeah.
Okay, and then duration for B is 4. So put 4, and then duration C is 6, and then 8. No problem, right?
No. Yeah, sure.
Okay, so now we go on to E. So you see the E here, it says the duration is 16. That's no problem, right? Before E is B and C. So you can see is before E is this B to E, and then C go to E. Can you see?
Yeah.
Okay, so this part you can understand. Now you can see B go to E. Behind there you see the table, the leg of finish to start. That means B finish and go to start E is 0. Can you see that value?
Yeah.
Okay, so you don't have to write anything. But you see this E from C go to E, you can see the value 10 there. Finish to start, C finish and then go to start E. Can you see that the column finish to start in the E, along the E there?
Yes.
Can you see C, and then after C is the 10, so that means from C finish C go to start E, there's a lag of 10. So write the 10 here, you understand?
Yeah. Okay.
So meaning I finish C, let's say this is I put there, is it days? Okay, let's say it's 10 working day. I finish activity C, 10 days later I start E. You understand the meaning? You
that
never
means-
understand.
That means after the activity C is finished, then it will delay for 10 days before starting the activity E, right?
Yes, that's the meaning. So that's right. You must know how to read the table. Okay, understand now? You don't look at the additional leg first. You just look at the first 4 columns. Okay, right? So next we go on to F. Okay, F is duration is 2, right? Right, is here. And then in front of F is D. Is here not? Okay? Right?
Yes.
To start, but no value, no lag. You see, that's why it's put 0 there. So next you go to G. Before G is, what is the value? Is F. Before G is F. Oh, I think I missed something, right? Did I miss something? No. Did I miss something? Oh, I think I should put before G. No, it's okay. Before G is F. So before G is this F here. So finish F and then go to G. It's 0. Okay? Is that okay? With duration 5. Is that okay now?
Yes.
Okay, so next one is H. So H, the value duration is 5. Okay? So in one H, that means there's nothing. Actually, in front H, there's no, in this case here, tentatively, this table here show in front there's no note before H. That's the meaning, none. Can you see none? Supposed to be nothing in front. Supposed to be nothing in front of H first. Later we add that one is additional lag. Okay. Last one, the I. Before I is you have is E and H. Can you see?
Yep.
Okay. So E go to H, no value. G go to H. This one supposed to go here because it's no space, so I cannot put all here. I just put here. So this one go here is also no value. So just finish E, go finish to start. The moment finish E, you start I. The moment finish G, you go and start I. The moment finish H, go to start I. Understand the last row? Okay now?
Yes.
Okay, now we go to the additional legs. Okay, come back to, you can see the column additional leg relationships. Can you see?
Yes.
Okay, so the first two, none. So nothing, no need to do anything. So you look at the row that is along C. Yeah? So it says finish to finish C to F. Can you see that column down?
Yes.
You see? So that means starting from C. So it's called what? Finish to finish C to F. C here, finish, go to F. So this is finishing point, this is finishing point. So you draw the arrow C go to F, finish to finish. And then you see the value lag of 5. You put the lag of 5 along this arrow here. Okay now?
Yeah.
Okay. So next one is none. Then the next one is finish to finish E to G. So you go to E, finish E, and then go to the finish of G. Can you write? Understand now? Finish of E, this is finish of G. Okay? Then the value is what? Lag of 9. So you write the lag 9 here along this line. Okay? Okay?
Yeah, yes.
So next one is none. Okay, following one. Start to start. G to H. So G start. Where is G? G is starting here. This is the starting point. Start of G go to H. You see? So this is the line G start, go to H the start. Okay now? Then with the lag of 6. Can you see now?
Yes.
Okay. So this is how you get to the diagram. Is that clear now?
Yes.
Okay, now we go on to forward pass, right? Okay, how to do forward pass? Okay, now remember V shape. 0 plus 2 equals to 2, okay?
Yeah, okay.
Okay, 2 bring to here because there's nothing here, no lag here. Just 2 bring, this one bring to this one here. Bring to B, bring to C, bring to D. No problem, right?
Yeah, no problem.
Okay, 2 plus 4 equals to 6 for B, okay, right? 2 plus 6 equals to 8 for C. 2 plus 8 equals to 10 for D, okay?
Yeah, okay.
Okay, so this 6 supposed to be bring here, but you see it's 18 because this is what? E is a merge activity. So you need to compare. So this value here is 6, but you see this one means 8 finish to start 10. So meaning this active finish, I must wait, just now you already explained, 10 days later, I will start this E. So you must 8 plus 10 equals to 18. So you see this one will be 18 here plus 18 and 6 compare 18 bigger, so put 18 here. Do you understand?
Yep, understand.
Okay, so 18 plus 16 equals to 34. So leave it there first. Now here you see this one here, finish to finish. This one here, 10 bring here is 10 because there's nothing like here. So just put 10. 10 plus 2 supposed to be 12 here, right? But why 13? So you see this one finish and then I also finish. So then it's 8 plus 5 equals to 13. You understand?
Yeah, understand.
Instead of 12, you see, so forward always take the largest one. So you take 13 instead of 12 here, right? So 13 finish, then you bring here, there's nothing here. So you put 13 here, okay?
Yeah.
Right? So 13 supposed to be plus 5, supposed to be 18, but why 43? Okay, now you look at this relationship here. So this finishing is 34. I finished, this one also finished 9 days later. So that means 34 plus 9 equals to 43. Instead of 13 plus 5, 18 here. You understand now? Okay?
Yeah, understand.
Okay. So now from this 43 here, okay, come here. So this 13, this one says start to start. I start 13 on the 13th day. I wait for 6 days later. I also start H. So 13 plus 6 equals to 19. Okay?
Yeah.
19 plus 5 equals to 24. So this one supposed to be 24 here, or there's a value 43 here, there's 34. So you compare 34, 43, 24. Which one is the largest? 43. So you put 43 here. Okay now?
Yeah.
43 plus 14, then you get 57. Okay now?
Okay. Yeah, I get it. Yeah, thank you, doctor.
So can you do the backward pass? It's minus. Okay,
Yes.
so you do it, same, it's the same way. You must take note, the lag one is a bit complicated. You do the normal way, but also take note of lag, the relationship. You just follow the same box, going backwards, minus, and then you compare if it is burst, pick the smallest value. Okay, now you write down the value at the arrow end of the arrow or at the starting of that arrow, then you can compare easily, right? So you do it slowly. Anyone finish with backward pass?
Doctor, I have a question.
Not yet, not yet. Very complicated. So you
Okay.
know how to, you need to know this because my test got something like this.
Hello, doctor.
Yes.
I have a question.
Yeah.
For the lag, do we need to, like, you specifically, for example, for lag 5, you start the arrow at the SL square and then you end at the EF square. Like, must we follow that, or we can put it anywhere on the square?
You have to follow the relationship. If it is start to start, that means from the starting point. See, for example, this G is start to start. From the starting of G go to the start of H. Otherwise, you will miss the calculation. So that means this is start to start. If you simply draw anyway, if you simply draw to the end, then calculation will be wrong. So if
Okay.
finish to finish, then you see this one is finished. This is from finish point, go to the finishing point. You understand or not?
Okay, I see.
Cannot simply draw one. Cannot simply draw. Actually, this one I prefer. Actually, by right, I should draw here and then draw here because it become like very complicated. So I just draw here is the start to the start. Okay. The I
Alright.
one is supposed to go to the front. Is easier, right? Okay.
Alright.
Any more? Anyone already finished backward pass? You have to calculate slowly and then look at the legs. Otherwise, calculation all wrong.
Doctor, I want to ask.
Yeah.
For finish to finish leg.
Which one?
For example, finish to finish leg E to G, leg 9. Why does it add with 13 for G? It just puts 43 for EF.
40. This is 34 plus 9 because it's leg 9. So 34 plus 9 is 43, right?
Yes.
So if you do forward, this one 13 plus 5 is 18. But which one is larger? When you do forward, always take the largest value.
Oh, you don't have to add with 13 plus 5.
No, 13 plus 5 is 18, right?
Yes.
Okay, so this one, if in this case go forward this way, 13 plus 5 is 18. But you see, this one also coming down here. So this one is to the finish. You see this called I finish this, 9 days later, I finish this. That's the meaning. So I have to add 34 plus 9 is 43. Which one is larger, 18 or 43?
43.
Yeah, so you always remember, going forward, you always take the largest. So you take 43 instead of this plus this 18. You understand now?
Okay, I understand.
Okay, backward, you always take the smallest. When you, after minus the leg, you take the smallest. When you come to the burst activity. Okay now?
Okay, thank you, Doctor.
Okay, welcome. Any more questions? Anyone don't understand, you better ask. It is a bit complicated with the legs. Anyone finish with backward pass, then you compare your answer with my answer. If anyone still don't understand, you better ask now. Then I explain to you how you get forward pass, how you draw the diagram, how to get forward pass, and later how you do the backward pass. So you must take note of the legs. You cannot simply draw the arrows. You must follow the relationship mentioned is finish to finish, finish to start, or start to start. Okay, anyone finish, just let me know, that I'll show you my backward pass answer and you can compare with my answers.
Doctor, I finished with backward pass already.
Okay. Anyone else want to see now? Okay, I show you my backward pass answer, then you can compare. Okay, do you get this? Is it same as mine?
Yes, doctor.
Good. Okay, so now you calculate the slack. So slack should be very easy, just minus only. And you tell me what is the critical path. Finish? What's the quicker path? What is the quicker path? Anyone?
ACEI.
ACEI.
I.
Okay. ACEI. I put ACEG. You put all ACI because you pick ACE. No, because there's no. Oh, let me see. Oh, yeah, you're right. I missed this one. I didn't notice this. You're right. ACEI. Yeah. Okay, this one is 0 because this one got 19 here. Your answer is correct. ACEI. So I make a mistake here. I should remove this. This one should not. This one should go here. Okay, so the line, this one is both 0. This one got 19 here. Okay. So it's ACEI. Okay, any question? Any question? So when you calculate, just need to be more careful, right? Understand? Anyone still don't understand with the lags calculation?
Doctor,
Yeah.
can I ask, in assignment, I mean in our project report, do we need to write the blue color number, the 8 and 27?
Not necessarily. That one is to show you that how to get the 8 instead of putting the 27. It just so that you don't miss the calculation. It's to compare between 8 and 27. You take the 8, the coming backward is the smaller. Same thing if you go forward, if there's a merge, then you put all the 3. It's just like here, I didn't put the 34, I didn't put the 43 and the 24 here. Then you compare and put the 43. You understand? That
Okay, thank you.
Illustration.
Okay, thank you, Doctor.
Not necessarily. You don't make mistake in calculation, that's all. Any more questions?
Hello, Doctor.
Yeah.
For the forward and backward, it should be tally, right? If like after we go back to A, it still will be tally with 2 until -2 equal to 0, right?
Yes, correct.
All right, thank you, Doctor.
Yeah. Any more questions? So if tally, not tally, that means something wrong in the diagram or something wrong with your calculation. Okay. Anyone still got question with this calculation? So when you apply, you have to learn to apply lags in your project network, your own project. So first you already have plotted your PBS, you got your WPs, then you go and decide the dependencies, which task dependent on which one first, or which activity. You can group a few WP to become one activity. Within one activity, group them under one particular activity, and then you write down all the label for activity and you start plotting this network diagram. Which one dependent on which one? It's just like you cannot conduct the survey until your survey form ready. You see, you have to design survey form, then you use the tool to develop the survey. With the tool ready, then you go and send out the email, then you can start collecting. So these are all the dependencies. And then can you apply lags? That means I do at the designing of the survey form using, let's say, Google form. At the same time, I identified the respondents, find their emails and so on. So those are in parallel. You can do it at the same time. Or you want to apply lags. After I started, it can be I started identify all the respondents. Let's say 2 days later, I start designing, the survey form using Google form. So it's up to you. You want to apply lags, then you learn better. Then you learn how to do forward pass, backward pass using the lags that you impose on your own project diagram. Okay? Any questions? You understand now how to do your network diagram for your project? You relate this, you apply this to your own project. Okay now?
Okay.
Okay. So if you got any question, you just send me an email. You plot the chart first. If you're not sure whether it's correct or wrong, then you just let me know. And then you send to me, and then I will check for you. But you have to show me, first thing you let me check your PBS first. If PBS correct, then you show me your network diagram. Okay, is that okay?
Okay.
Yes,
Okay, doctor.
Okay, good. If no question,
Doctor,
yes.
the midterm is, I mean, the midterm test is on 28th, right?
Yes.
What time is it?
2 to 3.
Okay. Thank you.
Okay, any more? Any more question?
Doctor.
Yeah.
This is for the PBS. I sent
Mm.
the email the other day and I've corrected the PBS. Do I send the email again or?
If you're not sure, then you can send to me. I will just check very quickly. Have a look again.
Okay.
Okay.
Sure.
Doctor.
Thank you, doctor.
Yes.
I'm from TG2 T5 and
Okay.
I sent the email like 2 weeks ago, but still no reply.
Okay. TG what? TG2 T5 ah?
Yes.
You said the diagram or the chapters?
The chapters. Including before we split into chapters, I've already sent one because you say that we can ask about like opinions and stuff, right? So do I need to send an email again?
Can you send an email to remind me, because I got too many, because sometimes I just go to do the master one, I forgot about, maybe I miss your one and then go to the others. You send me an email afterwards and then I go to check your one now.
Okay, okay.
Okay, any more? Any more question? Okay, if you're not very clear with this question that I said here, then you can just ask me again. I can explain again during the tutorial question. Is that okay? Any more? If you don't understand, I can explain now. If you want me to explain again.
We're fine. Yes.
You want me to explain again? From which part onwards?
No, I'm saying that we're okay with.
Oh yeah, okay. Okay. So if any question, then I'll see you on a tutorial session, and then you can ask me again if you don't understand this, how to draw this like that. And then by the way, I think next week is semester break, right?
Yes.
Okay, so next week tutorial.
I beg your
Okay,
pardon?
so I see you on Friday tutorial session. Any question, you send me an email. If